All right, so now for the famous Monty Hall paradox. And it's called a paradox because it gives a surprising result. It's not what you would expect. So let's set this up. Back in the 1970s, there was a game show called Let's Make a Deal. And it was hosted by a guy named Monty Hall. And on the game show, one of the games that they played, they were contestants were given the choice of three doors. Now, one of those doors, behind one of those doors, was a brand new car, which of course was what everybody wanted to win. The other two doors had goats. Those were, I don't know if they actually won a goat, but but they were just the consolation prizes, right? Or they weren't even prizes. You're basically winning nothing. Okay, so those are the ones you don't want. You want to win the car, right? So you were asked to, as a contestant, you would be asked to choose a door, and then you just choose a door one at random from the three doors, and then after you chose a door, Monty Hall would show you what was behind one of the two remaining doors. Okay. Now, of course, he would always reveal a goat, right? Because if he didn't show, he showed you the car, you lost and it's over. So he would reveal a goat, and then ask you if you want to keep or switch. If you want to keep the door that you first chose, or if you want to switch to the remaining closed door. Okay? And the question is, what should you choose? Should you switch and take the other door? Or should you just keep the door you have? Or does it really even matter? I mean, it seems like, you got two remaining doors. It's maybe a 50-50 chance. So why would it matter? Why would it matter to even whether you switch or keep your door? So that's the question we want to answer here. And I'm going to use a tree diagram to hopefully illustrate this paradox to you. Okay. I think most people would say, yeah, it doesn't really matter. Keep or switch. I got two doors to choose from. There'd be a 50-50 chance that the car would be behind one of those doors. But it's a paradox. So let's take a look at this. Let's draw this as a tree diagram. All right. So we have three doors, right? We have what do we have? We have sorry, we have behind one of the doors is a goat, right? We'll call him goat 1. Behind the next door is goat 2, and then behind the third door is the car. That's what you want to win, right? And your first stochastic event, right, is to choose a door, right? You got one of three doors to choose from. So your first chance event is choosing the first door. So this is your first choice. Okay, and those are the possible outcomes from your first choice. Now you don't know what it is at this point, right? It was you either chose a goat, one of the two goats, or you chose a car. And there's a 1/3 chance, right, of choosing of any one of these outcomes. Okay. So now Monty Hall is going to open one of the doors, but he's going to do it strategically. He's not going to show you the car. So if you chose goat 1, he knows what's behind the door. So if you happen to choose goat 1, then what's he going to show you? There's only one option. He's going to show you goat 2. 100% chance. If you chose goat 1, he'll show you goat 2. If you chose goat 2, right, there's a 100% chance he's going to show you goat 1, right? Because he's not going to show you the car, right? If you chose one of the goats, then the other doors are either a goat or car, and he's going to show you the other goat. If you chose the car, right, if your first choice happened to be the car, then he could show you either goat, and he's just going to choose randomly. He's either going to show you goat 1 or he's going to show you goat 2. And 50-50 chance of him showing you either one of those goats. All right. So that's what Monty Hall, that's the event that Monty Hall, of what Monty Hall shows you, right? So he's going to show you a goat, another goat, right? And it's just a matter of which goat he's going to show you. All right. All right. So next thing you have to choose. You have to choose, do you want to keep your door or do you want to switch? If you keep your door, really nothing changes, right? You had a 1/3 chance of choosing the card on the first choice, so you have a 1/3 chance, 1/3 chance of winning if you keep your first choice. If you keep your first choice. Okay, so that's, you're just keeping your first choice. Now the other option you have is to switch. Okay, if you switch, right, what are the possible outcomes? If you first chose goat 1 and Monty Hall showed you goat 2, and then you switch, right? You had goat 1, you're going to switch. You're going to automatically switch to the car, right? 100% chance you're going to get the car because, that was the only other door available. If you chose goat 2, Monty Hall, 100% chance he's going to show you goat 1. If you switch, you're going to get the car, right? Because that's the only thing left is the car. And if you switch, you're going to get the car, 100% chance. Now, if you chose the car and you switch, then you're switching to one of the goats. So if he showed you goat 1, you're going to get goat 2 if you switch, right? 100% chance. If you chose the car and then he showed you goat 2, then you're going to get goat 1, 100% chance. All right, so let's multiply those probabilities down these branches and see what the probabilities are. So if you chose goat 1, Monty Hall shows you goat 2. If you switch, you get the car. There's a 1/3 probability, right? 1/3 times 1 times 1. So there's 1/3 probability that that scenario, that particular outcome happens. If you chose goat 2, right, there was 1/3 probability that you would choose goat 2. Monty Hall is going to show you goat 1, and if you switch, you're going to get the car. There's a 1/3 probability that you're going to get the car. Now, if you just add up those two scenarios, right, those two scenarios, you're going to win the car. And you can see now, if you switch, you have a 2/3 chance of winning, right? That's your probability of a 2/3 probability. Probability of winning the car if you switch. Winning the car if you switch, right? Otherwise, you just have the 1/3. Well, so you have a 1/6 chance of winning goat 2 and a 1/6 chance, just multiplying those probabilities, 1/3 times a half. And so, that's a 1/3 chance of not winning if you switch. But a 2/3 chance, that's not too bad. That's better than 50%. So you are more likely to win if you switch. If you switch doors, you are more likely to win. In fact, you're going to have a 2/3 chance of winning the car if you switch, which is a surprising result, right? You first think, well, I've only got 2 doors to choose from. My first choice was random, and I have now I only have 2. There are only 2 doors left, and you'd think it would be a 50/50 chance, just by not looking at it in detail. You just kind of think it, just your first reaction anyway, is that you probably have a 50/50 chance, but that's not true. You actually have a 2/3 chance of winning if you switch. So you should always switch.